హాయ్ ఫ్రెండ్స్, ఈరోజు మనం హార్టుంగ్ గవర్నర్ గురించి చూద్దాం. ఓకే, ఈ హార్టుంగ్ గవర్నర్ వచ్చేసరికి ఏంటంటే స్ప్రింగ్ కంట్రోల్డ్ గవర్నర్ ఆఫ్ ది హార్టుంగ్ టైప్. In this type of governor, the vertical arms of the bell crank levers are fitted with spring balls with compress against the frame of the governor when the rollers at the horizontal arm press against the sleeve. So you are going to see this thing in with the setup of this governor first. Okay, so I'm going to draw axis line first here, and then now we're going to this is coming from support, and then now I am going to draw sleeve. Okay, now this is the rod, and then we'll going to extend this rod. Okay, and now here I am going to fix two rollers, 1, 2. Then here is link, and I am going to fix here also one link. Join these two links like this, and here to here also like this. And now we are going to see here one axis line, and then now here also we are going to see one axis line vertically, and equal distance I mean given here one roller support, here also given one ruler, and then join this is coming from bell crank lever. Okay, this setup is called bell crank lever. And now here we are going to fix one inside, we are going to fix springs. Because of this is acting with the help of springs. So then here I am going to fix some springs like this way. Just watch it. Okay, this is one spring, and then okay, inside of the box you can draw hidden lines. Okay, like this. Okay, and then we are going to see here springs, and now here also one spring like this. Okay, it's enough. We are going to fix something on here, so like this. And then now here also similar procedure you can take like this. Like this. Okay, you are going to fix like this. Here also springs. And now I'm going to draw cap. Okay, this is all our springs, and we are going to see here a support of this here vertical line like this, and then you can take some cap like this. This is the governor, you can see here. Also you can take like this. Now hatching. So these are cross sectional points. That's why we are going to show the hatching lines. This slide is completely end. ఈ విధంగా మనం హ్యాచింగ్ చేసుకోవాలి. దీన్ని ఏమంటామంటే సెక్షనల్ కట్ అని చెప్తాం. ఓకే, సో వాట్ ఈస్ ద పార్ట్స్ నేమ్స్? దిస్ ఈస్ కాల్డ్ bell crank, lever, and this is called sleeve, and this one is called roller. And then here I am going to draw one line, and similarly here also I am going to draw one line. This setup is called a frame, and then this is here is having spring balls, here also having spring balls, and then now this is spring. Okay, this is the segment diagram of Hartnug Governor. So then we are going to see free body diagram for this, and now similarly I am taken one axis, only this half section I am going to draw this. So this is ruler, this is link O, and then this is going to join like this, and this is extension part, and you just take this thing is like this cap. Okay, now here I am going to draw one spring like this. Now here one force is acting, spring force, and this is force is acting, frictional force. And here to here, look at this, this is the distance is called R. This is governor axis, we know very well. So governor axis, and then now here we are going to see this one. Okay, this part is coming from this, and this is this, and now here we are taking the spring is like this, and now here we are going to point, fixed point is called O, and then this is called X. Now here we are going to see downward, that is called mg/2. So this is called Y. Okay, this is the free body diagram for this. And now that means here to here distance you can take Y, here to here you can take X. So this force is called Fc, centrifugal force, and this force is called spring force. Yes. Okay, this is the free body diagram for this. And now we are going to see taking moments about O. సో పాయింట్ O దగ్గర ఫిక్స్ చేసి మనం కనుక మూమెంట్స్ తీసుకున్నట్లయితే FC into X that is equal to M into G by 2 into Y plus S into X. Okay, this is the taking moments about point O. S into X, this is coming from, this is the fixed point O, this is anti-clockwise direction, and these two forces are in clockwise direction. That's why we can take opposite. Okay, and now here we see S is equal to spring force and FC is equal to centrifugal force, and then M is equal to mass of sleeve, X and Y is equal to length of the vertical and horizontal arm of the bell crank, arm of the bell crank lever respectively. Okay, so this is the totally Hartnug Governor యొక్క procedure, and now we are going to see one problem. And now look at this problem in here. In a spring controlled governor of the Hartnug type, the length of the ball and sleeve arms are 80 mm and 120 mm respectively. The total travel of the sleeve is 25 mm. In the mid position, each spring is compressed by 50 mm and the radius of rotation of the mass centers is 140 mm. Each ball has a mass of 4 kg and the spring has a stiffness of 10 kilonewton per meter of compression. The equivalent masses of the governor's gear at the sleeve is 16 kg. Okay. Neglecting the movement due to the revolving masses when the arms are inclined. Okay, determine the ratio of the range of speed to the mean speed of the governor. Find also the speed in the mid position. Okay, right. So now we are going to see here and draw the solution and given data first. Solution given data. Okay, and first position we are going to see here FC, S, O, this is Y, this is X, and this is R. You can take this capital NG by 2. Okay, and now here is governor axis. This is called governor axis. Okay, and then now we are going to see in here, this is mean position. Okay, now minimum position we are going to see here, minimum position. So in here I am going to draw one axis, okay, for fixing point O, and the angle inclination in here is I don't know, but I'm going to take some of the angle, that is you can take the theta, and now this is FC and this is called S. Okay, now this is the distance is called X. Now Y, so exactly you can draw this thing is with perpendicular like this 90 degrees. Okay, you can take L shape, and then this is called Y. So here it will put R1. Okay, R1. Now then we can take this is 1, this is 1, and now here also you can take 1. Here 1 theta. Here theta is equal to 90 degrees, but here theta 1 is we don't know. Okay, and then now here the distance here to here is called x1. Similarly here to here the distance is called y1. Okay, now we know very well this is capital M G by 2. Why? Because the mass never change in here. Okay, so now here the axis at the same time point R, we can take this distance is called H1, and now here look at this, here to here is called I don't know, and then O point. Look at this O point. Okay, look at this O point. Here to here distance is called R. See this. Okay, and then now here to here is R. Because of we can see point O to governor axis is called R. That's where we are going to fix. Okay, O to governor axis is called R. So then this is O line and this is governor axis. So this is governor axis. So then governor axis is called R. So FC, the R will be changed in here some distance. You can take this is R1. Okay. So what we changes is called here is minimum position. Okay, now I am going to here draw the maximum position. So now this is called governor axis. Okay, and now I am going to take horizontal line, but its maximum position here it picks O. Here I am taking one axis, another axis. Why? Because the line will be going like this. See, here is called FC and here is called S, and now here this is the angle is called theta 2. Okay, so this is called X, we know very well, and then now here to here distance is called X2. Okay, here to here distance is called X2. Now the position here to here and O axis, this axis to this one, governor axis, this is called R, then this is called R2. Okay, and now this is the position in between the angle, this is the distance is coming from here, this is you can take A2. So we are going to see perpendicular line, you can draw like this 90 degrees. Okay, so this is called theta 2 and Y. So this is R and then this is called R. So some vertical force is acting, mg by 2, we know very well. Okay, and then now to see here to here distance you can take H2. here is you can take h1 and here is you can take h2. Okay, and now see this to this O to R distance is called y2. O to R distance is called y2. Okay, and here also we are missing one point. What is that? R is there, R1 is there. What is this distance? You can call A1. Here is you can take A2 and here is you can take A1. Okay, so this is the B point, and diagram is called maximum position. Now we know very well this is called Governor axis. Okay, see this is mean position, minimum position and maximum position of Hartnug Governor. Okay, and then we are going to see here given data. So write down given is x is equal to 80 mm, that is called 0.08 meter, y is equal to 120 mm, then that is equal to 0.12 meter, h is equal to 25 mm, that is equal to 0.025 meter, and then r is equal to 140 mm, that is equal to 1.14 meter, and m is equal to 4 kg is given, s is equal to 10 kilonewton meter, that is equal to 10 into 10 to the power of 3 Newton meter, capital M is equal to 16 kgs. Initial compression is equal to 50 mm, so that is called 0.05 meter. Okay, and now we see we are going to solve this one. Omega is equal to mean angular speed in radians per second, and is equal to mean speed in rpm. So we know that Fc is equal to centrifugal force is equal to m into omega square into r. So then 4 into omega square into 0.14. Then this value is called 0.56 omega square newtons. Okay. So now spring force. Now here another force is there, spring force, that is called S. You see S. Okay. So S is equal to stiffness into initial compression. So that is 10 into 10 cube into 0.05. So that is called here 500 newtons. Okay. Now taking moments about A. So taking moments about point O. So can take point O. Here is point O. Then Fc into x, that is equal to S into x plus m into g by 2 into y. You can take this and this. Okay. So now here value substitute here, that is equal to 56 omega square into 0.08, that is equal to 500 into 0.08 plus 16 into 9.81 divided by 2. So that is into 0.12. Now calculate total this thing, we will get the omega finally. Omega is equal to 33.2 radians per seconds. Okay. Okay, once మనకి ఒమేగా వచ్చినాక n is equal to, we know very well, that is coming from here, omega into 60 divided by 2 pi. Okay, that is called omega is equal to 2 pi n by 60 sin. So omega is equal to 2 pi n by 60. Now I need n, omega into 60 by 2 pi. So 33.2 into 60 divided by 2 pi. We can calculate this, we will get the answer 317 rpm. That's the answer. Okay, and now we are going to see here ratio of range of speed to mean speed. Okay, ratio of range of speed to mean speed. So let omega 1 is equal to minimum angular speed and omega 2 is equal to maximum angular speed. So then n1 and n2 is equal to corresponding minimum and maximum speeds in rpm. So then here from the geometry of the figure B, you can see geometry of the figure B. Okay, then here we are going to write this one, r minus r1 by h. Oh, I'm sorry, this is called B and this is called C. That's the point. Here is B. This is A, B, C. So then here is B. So R1, R minus R1, that is equal to X. So that is equal to X. And now H is equal to Y. So you can write down this one. R1 is equal to R minus H into, that means H1 into X by Y. That is equal to 0.14 minus 0.025 divided by 2 into 0.08 divided by 812. So we can solve this, we will get the answer here. This is the answer. Okay, why we are going to take H value is 25 actually, that is meters, 0.025, and then here is the half of the length. Okay, thus we can take H1 is equal to, since H1 is equal to H by 2. Okay, now we are going to here see force, centrifugal force. Okay, m into omega 1 whole square r1, that is called 4 into omega 1 square into 0.132. So 0.528 omega 1 whole square in newtons. Okay, so here is, you can take r value is given, so that r value we are going to substitute simply in here. Okay, next you are going to see in here r already, you can find this r value, so then you are going to find which r1 is, you can find out. Okay, the value we can here we substitute. Okay, next we are going to see S. Thus S value is, we know very well, initial compression, that is given, minus r1 into stiffness. Okay, so then here we are going to see 0.05 minus 0.14 minus 0.132. okay, into stiffness is 10 into 10 cube. Okay, finally we can solve this, we can get 420 newtons per S. So as easily, similarly we know very well, taking moments about taking moment about and then now here we see fc1 into x. I'm going to write here fc1 into x, that is equal to s1 into x plus capital M into g by 2 into y. Now substitute all values. We know all values, okay. I am simply substitute here all values into 0.02. Okay. Now calculate entire this thing. We will get omega 1, that is called here 32 radians per second approximately. And then now here we are going to see n1 is equal to omega into 60 by 2 pi. So then this is called 1. Okay, that is called that 2 into 2 pi. You can solve this 305.5 rpm, it will get. This is the variation speed of this thing. And now we are going to see considering figure A, B, C. Now we are going to see maximum position. Okay, maximum position. Then we are written here R2 minus R1 by H2, that is called x by y. In same similar procedure we are going to see here R2 is equal to R minus H into x by y, that is equal to R is okay, and here we can take H2. So then here H2 is also coming from H by 2. So can take half of the length, given length, half of length, that means how much? 0.025 by 2 into 0.08 divided by 1, that is equal to 0.148 is the answer. 0.148. okay, this is the answer for this meters. Once you get the R, so we know that fc2 is equal to omega 2 whole square into r2. And now substitute these values here, 0.148. You get the answer for this 0.592 omega 2 whole square. And now spring is equal to, we know very well, initial compression plus R minus R2 minus R into stiffness. So then here initial compression is given, that is called here 0.05 plus R is equal to 0.148 minus R is 0.14 and then into 10 cube. So finally that is equal to here 580 newtons. So spring వచ్చేసిన తర్వాత మనం ఏం చేయాలంటే టేకింగ్ మూమెంట్స్ అబౌట్ O. So taking moments about point O. So then what happened in here? fc2 into x is equal to s2 into x plus m into g by 2 into y. Now substitute this all values in here. 0.08, that is equal to 580 into 0.08, 16 into 9.81 divided by 2 into y. What is the y value here? 0.12. Then you can calculate here, solve this thing, we will get omega 2 finally. that is called 34.32 radians per second. Then we know very well n2 is equal to omega 2 into 60 by 2 pi. Then 34.32 into 60 by 2 pi. So n2 is equal to 327.7 rpm is the answer. Now range of speed. Okay, so range of speed, that is equal to n2 minus n1, that is equal to 327.7 minus 305, okay, that is equal to 2.2 rpm. This is the range of speed, and therefore ratio of range of speed to mean speed, so that is equal to n2 minus n1 divided by n, so that is equal to 22.2 divided by 317, that is called 0.07, so or 7%. This is the answer for range of speed ratio. Okay, n value, where it will come, n value means you are going to see here. First you can find out that n value is in here, 317 rpm, n is there. Okay, so that is in mean position. Okay, so this is the total procedure to solve the problem in Hartnug Governor. Okay, thank you.